All right, last part of section 8.3, and I will tell you right now, calculating confidence intervals for a mean difference, in other words, matched pairs. This will be something that is extra credit on the assessment. It's questions 69 and 70 on the assignment. You may have noticed those are in parentheses. So they really will be optional extra things. There'll be partial credit on the assessment, so pay attention or not, that's up to you. What is a matched pair? Well, here's what's meant by that, right? We did matched pairs back when we were doing chapter 4, way back at the beginning, how to collect data. Some examples. Two different seeds of the same type, they're planted in the same spot. One gets a treatment, one doesn't. How do we compare those? We do this with different pairs. Okay, in the same pot or same thing, we get some that get a treatment, some that don't. We're comparing this one with this one. We're not comparing this pot over here. We're comparing within this pot. Some get the treatment, some don't. An elementary school teacher uses a matched pair design to pre-test and post-test for each student, right? Student A, pre-test versus post-test. Did they do better or not? I can't compare student A's pre-test and student B's post-test. I have to compare student A to student A, student B to student B, and so on. Another one, and we're going to talk through this example in just a minute, whether caffeine addicts, right? Caffeine addicts, if they get real caffeine or if they get a caffeine placebo, doesn't make a difference. And so, but we have to compare this person with the placebo or this person with the actual caffeine. We can't compare one person with actual caffeine and a different person with a placebo because they might react differently. So we're comparing a person with themselves, getting the treatment and not. That's what makes it a matched pair. Each person or each seed or each pot, whatever, gets both treatments, and then what we do is we compare those two results. So when we do this, we're going to do one sample tease to look at the differences between them. So here's the story in this one. We've got 11 people who are dependent on caffeine. I don't know what that means exactly. Each subject was barred from coffee, colas, or other substances containing caffeine. Instead, they get capsules containing their normal caffeine intake. During a different time period, they took the same looking capsules except they didn't have caffeine in them. Now, they don't know which one they're taking and which one they're not. They just say, here, take your caffeine pill. Here, take your pill. The order was randomized. In other words, some people got the caffeine pill for the first how many weeks, and then the placebo for the second how many weeks, and some people had it the other way around. One of the tests was some sort of depression score. Now, the Beck Depression Inventory, I don't know. I don't know anything about that. All I know is higher scores mean you're more depressed. Like the caffeine isn't making you feel better. I don't know. Construct and interpret a 90% confidence interval for the mean change. That means, you know what? I don't care what anybody's actual scores were, because there are some people that might have very low scores with or without caffeine. And there might be people that have very high scores with or without caffeine. So what I really need to do is compare their score with and without caffeine and see if there's a change there. So we're going to construct and interpret a 90% confidence interval for the mean change in depression score. The change, not any of their individual scores, but how much difference is there between those. So, as always, we need to check the conditions, right? This, in Darren's state plan to conclude, here's the state. The plan is checking your conditions, and here they come. The first check that we have to do is, was it random? Now, the truth is, we don't know anything about how these 11 people were selected. But here's what we're really checking. Again, I don't care about subject number one's scores with caffeine or without. What I really care about is the difference between them. If I take 16 minus 5 and 23 minus 5 and 5 minus 4 and 7 minus 3, if I take those, I'm interested in this. This is the list that we're actually going to be working on. This one had a difference of 11. This one had a difference of 19. This one had a difference of 1. This one actually had a difference of -1. That's the list that we're interested in. And so in terms of randomness, what we're looking at is, were the treatments randomized? And they were, because it says the order was randomized. In other words, half of the people got the actual caffeine pill the first period of time and the placebo the second period, and half the people had that reversed. That's what we mean by randomness in this case, because this is the list that we are interested in. Independence, the 10% condition. We have a sample size of 11 here. Are we pretty sure that, and it's out of the population, we don't know exactly, and it doesn't tell us if this is the population, it's the staff at our school, or if it's all human beings or what. We're assuming that sample of 11, there's at least 110 people out there. If that's true, then we can go ahead and use our standard deviation formula, which we will. The check for normality, okay, normality, because it's not really normal, we're looking for a T procedure, is, let's see, is the population itself normal? We don't know. Is the sample size over 30? No, it's not. But T procedures are robust. As long as there's no crazy outliers or no crazy skewness, we can go ahead. Mr. G went ahead and he plotted these. -1, 1, 1, 3, 4, 6, 6, 11, 13, 18, and 19. Those numbers, and if you look at this, there don't appear to be any crazy outliers. So we say we're going to assume that it's okay to do a T procedure. Frankly, I would have made a number line with these 11 dots on it. Those dots would line up and they would show that it's not quite symmetric, but not crazy out of line either, so we would go ahead with T procedures. Now, here's where the actual calculations would happen. What we would need, X bar, remember, that's our statistic from our sample. 11 plus 18 plus 1 plus 4 plus ... divided by 11 would equal this. The standard deviation, if we put those things in our list, and find the standard deviation of those, that would go right there, over the square root of 11. We would have to do a little bit of work to find out what T star is. What is the critical T value for a sample of size 11, in other words, 10 degrees of freedom, and we would fill this in. I'm going to show you in a second how to do this in your calculator, and it's really easy. But he's going to go through and do the calculations first. The mean of these numbers is 7.364. He did an inverse T, and I believe this was supposed to be a 90% confidence interval, so an inverse T using 5% and 10 degrees of freedom gave a critical value of 1.812. This is the standard deviation of those numbers. Finishing the calculations gives this interval. Okay, crunching the numbers, this point estimate, this margin of error gives this confidence interval. Now, stay tuned, because what I want to do is I want to show you how to do that on your calculator. Here's my calculator, blank screen. What I did before is I went Stat, Edit, and I entered. This was the actual caffeine pills. I believe this was the placebo, but we have not yet found that difference list. This is actually really easy. I want list 1 and list 2. I want to take list 2 minus list 1. So I put my cursor at the top of list 3, and I'm going to tell my calculator, hey, what I want you to do for list 3, I want you to take list 2 minus list 1. I want list 3 to equal whatever list 2 minus list 1 is, and there it is. This is the same as the list that Mr. G had when he found the differences. Now here's the magic. List 3 is where that difference list is. So I'm going to go to Stat, scoot over to Tests. What I'm trying to make here is a T interval. It's an interval based on the T distribution with one sample. And I'm going to tell my calculator the data is in list 3. I want a confidence level of 90%, 0.9. Click Calculate, and it says, oh, do you mean this? The mean was 7.4. The standard deviation was 6.92, like he said. Here's the interval. This is the same interval that he got by doing the calculations. The final part, that's the do. Here's the conclude. Now notice this, in his conclusion, 95%, I'm 90% confident that the mean difference in depression scores for all caffeine addicts is between 3 and 11. Here's the thing. He points out that that difference was found by taking placebo minus caffeine. If I take placebo minus caffeine, and that's a positive number, it's somewhere between 3.5 and 11, that tells me people were more depressed when they had the placebo than when they had caffeine. Here's why this is important. If we had done 5 minus 16 and 5 minus 23 and 8 minus 14, these would have all been negative. I would have had to have told, and then this confidence interval would have been negative numbers between negative 3.5 and negative 11. Then I would have to tell my reader, I did that difference doing caffeine minus placebo. In other words, the people who had caffeine were negative or less depressed. This order makes a huge difference. You can do it either way, but you have to tell your reader which way you did it. Otherwise, I can't tell. Does that mean they're more or less depressed when I found the difference? You have to tell which direction you did that. Otherwise, that's it. And so, and again, this will be extra credit, but I want you to know here's how it can be done.